Ever since the Mariner 4 mission to Mars in 1965, we have been left with the impression that Mars is a cratered and moon-like planet, cold, dusty, and hostile to life, except perhaps for primitive microbial life forms. NASA appears to be heavily committed to maintaining this bleak image of Mars so that humanity will be distracted from seeing the obvious markings of a highly developed civilization that at one time inhabited the planet. Many investigators, such as Richard Hoagland, have focused on exposing the presence of small and moderately sized artifacts, such as the famous Cydonia face and nearby pyramids. While these are important, they distract us from the most obvious and enormous artifacts that make up the very topography of the planet. I am talking about mountains and craters and massive landforms that we are heavily conditioned to assume are natural formations. In fact, our conditioning is so complete that to suggest that the topography itself is artificial will cause most people to immediately turn away without even examining the evidence. And I guarantee you that the evidence is so credible that you would have to go into cognitive dissonance to dismiss it. This series of episodes on Martian artificiality is intended to break the spell that NASA has cast on our perception of Mars. The first episode is directed towards familiarizing you with some of the most important features on Mars, so as to give the viewer some orientation. We are all familiar with the continents and oceans on planet Earth, but we have very little background as to how the topography of Mars is arranged. First, let's look at how Mars is positioned with regards to the other inner planets of the solar system. This picture shows that on average, Mars is about 50% further from the Sun than the Earth. This means that it is going to receive a lot less sunlight and hence can be expected to be colder than Earth. Here you can see a size comparison between Earth and Mars. Its diameter is slightly larger than 1/2 that of Earth. Since it is smaller than Earth, it has less mass, and if you were on Mars, you would only weigh about 38% of your weight that you have here on Earth. You would also have to wear a spacesuit on Mars because its atmosphere is less than 1% that of Earth's, and its atmosphere is composed 95% of carbon dioxide with less than 1% oxygen. You would quickly freeze to death without protection since the average temperature is a very chilly -63 degrees Celsius. But it can be as high as +27 degrees Celsius at the equator on a sunny day. The length of day on Mars is very close to that of Earth, being only 39.6 minutes longer than our 24-hour day. NASA uses the term sol for a Martian day. The Martian year is almost twice that of the planet Earth, being 687 Earth days long. So basically, the surface of Mars is very inhospitable to human life. But was it always so? Are there other ways to survive very comfortably on Mars, such as in biospheres hidden within large pyramids, mountains, or even beneath the surface of the planet? Let's take a closer look. Let's imagine that we have just blasted off from Earth and are heading towards Mars in our warp speed spacecraft. When we reach Mars, we insert ourselves into a circular orbit. We have a special instrument aboard which visualizes the planet by bouncing laser beams off the surface. The time it takes for the beams to return allows us to see the planetary surface in terms of elevation. Such an instrument was used by the Mars Global Surveyor spacecraft, which made approximately 1 billion measurements between September 12, 1997 and the end of June 2001. The instrument was called the Mars Orbiter Laser Altimeter. Since there are no oceans on Mars, we can't reference elevation to sea level. Hence, NASA chose a different way to express elevation on Mars. It referenced elevation to the elevation where the atmospheric pressure is equal to 6.1 millibars. This elevation level is called datum. A convenient way to quickly see the elevation of different regions is to color code the elevations. Regions 5 kilometers or more below the reference elevation show up as purple. Regions 4 to 5 kilometers below show up as blue. Regions 0.5 to 4 kilometers below show up as green. Regions from minus 0.5 to plus 0.5 kilometers from reference show up as yellow. 0.5 to 2 kilometers as orange. 2 to 4.5 kilometers as red. 4.5 to 6.5 kilometers as maroon. 6.5 to 11.5 kilometers as gray, and more than 11.5 kilometers as white. By doing this, the picture of Mars that is obtained is quite stunning. The first thing to notice is that the elevation of the northern hemisphere is much lower than that of the southern hemisphere. The blue and green areas suggest that there may have been ancient oceans in the northern hemisphere. Regardless, they are now totally dry. The blue areas themselves are called planetiae, which means plains. They have far fewer craters than the southern hemisphere. The southern hemisphere is marked with many large craters, and it has an elevation which ranges from about 1 to 3 kilometers above reference, which is very high when you consider that the average elevation of land on Earth is only about 0.8 kilometers above sea level. The southern hemisphere is also home to 2 enormous holes in its surface, so large that they are called basins rather than craters. I am now going to point out key features on Mars that everyone should be familiar with. The first of these is an enormous area of elevated terrain, which is called the Tharsis Rise. I am going to place our spacecraft over the middle of the Tharsis Rise and draw an outline around it. From this, we can see that the Tharsis Rise is an absolutely huge tract of terrain. It is elevated to a peak of about 10 kilometers and extends about 5,000 kilometers across. It covers an area of about 18 million square kilometers, or almost twice the size of the United States. Thus, it is actually an enormous spread-out mountain having the height of Mount Everest. Is it possible that it hides a huge biosphere beneath its surface, which could have a ceiling height of about 10 kilometers, which is high enough to allow for a small spacecraft to fly within it? Now let's fly our spacecraft northwards. North of the west side of the Tharsis Rise, there is another huge spread-out mountain called Alba Mons. If one counts the widespread lava flow fields, this mountain stretches an immense 3,000 kilometers east-west and 2,000 kilometers north-south, which is even beyond the outline that I have drawn. Despite the huge area covered by this mountain, at its highest point, it reaches an elevation of only 6.8 kilometers, or 22,000 feet. Going southwards now, there are 3 huge mountains arranged in a row on the western edge of the Tharsis Rise. They are known as the Tharsis Mounts. Not only are the 3 mountains aligned, but they are also equidistant from one another. Ascraeus Mons is the northernmost of the 3 and is the tallest at 18.2 kilometers. It has a diameter of 480 kilometers. Pavonis Mons, the middle mountain in the chain, is the smallest of the 3 mountains, measuring about 375 kilometers across and standing 14 kilometers above reference level. Its name means peacock in Latin. The southernmost mountain, Arsia Mons, rises to an elevation of about 17.8 kilometers and has a diameter of 435 kilometers. It has the largest volume of the 3 and is approximately 30 times the volume of Mauna Loa in Hawaii, the largest volcano on Earth. About 1,500 kilometers west of the Tharsis Mounts is a 4th mountain called Olympus Mons. Olympus Mons is the largest planetary mountain in the solar system. It is a shield volcano, 624 kilometers in diameter, and it covers an area approximately the size of Italy or the state of Arizona. It rises to a height of about 25 kilometers from the terrain at the bottom of the mountain on its west side, making Olympus Mons almost 3 times the height of Mount Everest. The volcano's outer edge consists of an immense cliff, up to 8 kilometers in height. About 4,400 kilometers to the west of Olympus Mons, there is a second major group of Martian mountains located on another rise called the Elysium Rise. This rise occupies an area of about 4 million square kilometers, which is close to half the size of the contiguous United States. It has an elevation of approximately 5 kilometers at its highest point. There are 3 large mountains on this rise. The westernmost mountain is called Elysium Mons, and it is the largest mountain of this group, having an elevation of about 16 kilometers. Its diameter is about 240 kilometers. To the east of Elysium Mons are 2 smaller mountains called Tholai. The northern smaller mountain is called Hecates Tholus. It has a diameter of 180 kilometers and a height of 5.3 kilometers. The southern smaller mountain is called Elbor Tholus, and it has a height of about 4.5 kilometers and a diameter of 160 kilometers. We will now go about 79 degrees west of Elysium Mons, and then head south to about 41 degrees south. Here we can see an enormous hole in the Martian landscape which extends approximately 2,300 kilometers from east to west. This is known as the Hellas Basin. Hellas is the Greek word for Greece. The altitude difference between the rim and the bottom of the Hellas Basin is over 9 kilometers, which is enough to allow Mount Everest to hide itself quite nicely inside. At this great depth, the atmospheric pressure is about 12.4 millibars, or more than twice that at the datum elevation. The Hellas Basin is so large that it could hold enough water to cover the entire planet to a depth of about 195 meters. Going westwards about 111 degrees brings us to another huge crater called the Argyre Basin. This basin is about 4,600 kilometers west of the Hellas Basin. What is most interesting about the Argyre Basin is that it has no clear perimeter, which is not what you would expect if this landform were caused by a tremendous impact. Hence, the diameter of the Argyre Basin is controversial, but it is generally accepted to be greater than 1,500 kilometers. The basin drops to about 5.2 kilometers below the surrounding plains. Its name refers to Argyre, a mythical island of silver in Greek mythology. The final important feature on Mars that I will show you lies north of the Argyre Basin. It is a spectacular system of canyons called the Valles Marineris. The canyons run east-west for about 5,000 kilometers and have a depth of up to 9 kilometers beneath the surrounding landscape. The Valles Marineris is more than 10 times the length of the Grand Canyon in Arizona and is over 6 times as deep. With this, you now have an initial framework which will help you to navigate Mars. In future episodes, I will provide you with proof that with the exception of the Tharsis Rise, all of the sites which I have shown you can be proven to be artificial. Not only are they artificial, but also they are connected to one another to create a unified spherical sculpture, which has a profound message to tell. While I believe that the Tharsis Rise is also artificial, I have no evidence to prove it. So in quick review, we have the Tharsis Rise, Elba Mons, the Tharsis Monts, Olympus Mons, the 3 Elysium Rise Mountains, the Hellas Basin, the Argyre Basin, and the Valles Marineris. The next episode will focus on the ancient coordinate systems which were used by the early Martians primarily to create numbers reflecting sacred geometry. And like the coordinate system we use on Earth, they were also used to locate position on the planet. Full documentation for the material to be presented in this series of videos can be found in 3 recently published books. The first book, Intelligent Mars 1, Sacred Geometry of the Mountains, Did Da Vinci Know?, deals with the artificiality of the major mountains on Mars. It shows that the major mountains are artificially arranged in patterns which reflect sacred geometry. The second book, Intelligent Mars 2, Code of the Craters, demonstrates that many Martian craters are the result of engineering as opposed to arising from impacts from outer space. The third book, Intelligent Mars 3, Ohm and the Architect, shows that the entire planet of Mars is actually a massive spherical sculpture which encodes sacred scripture. Its topography tells the story of creation by a primordial Ohm sound and other progenitors. These 3 books can be obtained from Amazon and other online bookstores. Thank you for watching.